AI agents are autonomous systems acting as digital teammates, performing tasks and making decisions without constant human input. They operate with a goal and context, enhancing efficiency and productivity. These agents are pivotal in complex workflows, seamlessly transitioning tasks from one agent to another, ensuring smooth operations and effective task completion. Agent orchestration is the coordination of multiple AI agents to collaboratively tackle complex tasks. Imagine a workflow where a research agent gathers data, an analysis agent processes it, and a summarizer agent compiles the findings. This division of responsibilities enhances efficiency and effectiveness in achieving sophisticated objectives. Application programming interfaces are crucial for enabling communication between software applications. They allow seamless integration of generative AI tools into existing workflows, enhancing efficiency and functionality. By leveraging application programming interfaces, developers can easily incorporate AI capabilities, streamlining processes and fostering innovation in AI-driven environments. AI bias mirrors human prejudices in training data, leading to unfair or inaccurate outputs. Addressing bias is crucial for ethical AI development, ensuring fairness and accuracy. This involves scrutinizing data sources and refining algorithms to mitigate bias, fostering AI systems that align with human values and ethical standards. Chain of thought prompts models to think step by step, enhancing reasoning and decision making. This method is particularly useful for debugging AI outputs, ensuring more accurate and reliable results. By guiding models through a structured thought process, chain of thought helps in refining complex problem-solving capabilities. Context length, or context window, defines the amount of information a model can process simultaneously. Larger context windows enable handling more complex tasks and longer prompts, crucial for effective AI performance. This capability is essential for models to manage intricate inputs and deliver accurate outputs, enhancing their utility in diverse applications. Embeddings are numeric representations of words or concepts in vector space, crucial for understanding meaning and relationships. They enable large language models to comprehend and detect similarities, enhancing artificial intelligence's ability to process and relate information effectively. Ethical AI is crucial for ensuring fairness and transparency in AI systems. It aligns AI development with human values, preventing harmful or biased outcomes. This approach is essential for building trust and accountability in AI technologies, ensuring they serve society positively and equitably. Fine-tuning enhances AI models by training them on specific datasets, improving performance in targeted domains like medical or legal fields. This process tailors pre-trained models to excel in specialized tasks, ensuring they meet domain-specific requirements effectively. Faceless channels leverage AI-generated avatars to create content on platforms like YouTube and TikTok, enabling creators to produce videos without appearing on screen. This approach allows for anonymity and scalability, making it easier to maintain a consistent content output while focusing on creativity and engagement. Generative AI is revolutionizing content creation by mimicking human creativity. It generates text, images, audio, and more using learned patterns to produce innovative outputs. This technology empowers creators to explore new possibilities, enhancing productivity and creativity across various domains. AI hallucinations occur when models generate confidently incorrect responses, often due to lack of reliable data grounding. This is prevalent in large language models and poses challenges in ensuring accurate outputs. Mitigating hallucinations is crucial for maintaining the integrity and reliability of AI-generated content. Inference involves applying a trained AI model to new data, generating predictions or outputs. Unlike training, which constructs the model, inference focuses on utilizing the model's learned patterns. This process is crucial for deploying AI solutions effectively, ensuring they provide actionable insights and accurate results in real-world applications. AI interfaces are crucial for user interaction with AI workflows. They include forms, chat interfaces, and widgets, ensuring a seamless user experience. These interfaces bridge the gap between complex AI processes and user-friendly applications, enhancing accessibility and usability in AI-driven environments. Human judgment is pivotal in AI deployment, acting as a filter for AI-generated options. It ensures relevance and ethical alignment with desired outcomes, safeguarding against biases and inaccuracies. This critical oversight maintains the integrity and effectiveness of AI systems, balancing technological capabilities with human values and ethical considerations. Large language models are AI systems trained on extensive text data, enabling them to generate human-like responses and answer questions. They form the backbone of many AI applications, enhancing capabilities in natural language processing and understanding. These models are pivotal in advancing AI's ability to interact seamlessly with humans. MCP servers are crucial for contextual routing in large language models, enhancing memory handling in voice agents. They are integral to agentic systems, ensuring robust performance by grounding large language models effectively. This technology supports seamless artificial intelligence interactions, paving the way for advanced prompt engineering, where precise instructions yield reliable artificial intelligence outputs. Prompt engineering is the art and science of crafting precise instructions for artificial intelligence to ensure reliable outputs. It blends creativity with technical expertise, crucial for effective artificial intelligence interaction. This skill is essential for developers aiming to optimize artificial intelligence performance and achieve desired outcomes in complex systems. Prompt chaining involves linking multiple prompt response cycles to tackle complex tasks in sequential steps. For instance, it can start with research, move to summarization, and end with publication. This method enhances task efficiency by breaking down larger objectives into manageable parts, ensuring a structured approach to problem solving. Understanding artificial intelligence terms enhances effective use, crucial for practitioners and enthusiasts. This knowledge encourages informed artificial intelligence development and deployment, ensuring systems are fair, transparent, and aligned with human values.